So here's an interesting little result that if you look at consecutive natural numbers, the sum of cube is in fact the same if you sum the numbers and then you whole square it. So 1 cube is equal to 1 square. Well, that's not really very surprising, but the point is that 1 cube plus 2 cube is the same as 1 plus 2 whole square. 1 cube plus 2 cube plus 3 cube is the same as 1 plus 2 plus 3 whole square, and in general 1 cube plus 2 cube plus 3 cube all the way to sum n cube is always equal to 1 plus 2 plus 3 all the way to sum n whole square. Now this is something that is actually pretty easy to prove by induction, because you can prove that the sum of the first n cubes is equal to its formula turns out to be n square n plus 1 whole square divided by 4, and the sum of the first n natural numbers from r1 to n turns out its formula turns out to be n plus 1 divided by 2. Now you can see that if you square it you will get to the other side. In other words, if this squared is equal to this thing, which is what we wanted. But here I'm going to show a little different proof, which is more nicer pretty much. And for that, what I will do is I will first start out with 4 squares that are of length 1. So here's first square, second square, third. Let me draw a bit more neat. So these are 4 squares of length 1, and I will call this my first stage, let's say. Now what I will do is I'm going to wrap this first stage figure by squares of length 2. So here's my square of length 2, wrap it around on all 4 sides, and after we do this we're going to fill in the corners, and this is what I will call my second stage. And just to be clear, to get to the third stage I will wrap this around with squares of length 3. So and then we fill in the corners. So these are boxes of length 3, and this is what I will call the third stage. And also one more thing to note is that it is always possible that if you're at any nth stage, it is always possible to get to the n plus 1th stage. So if you're at nth stage, your box will look something like this. You can always get to the n plus 1th stage, which means that you can always cover this up using boxes of length n plus 1, and that is always possible because in the nth stage this certain length is always n plus 1 multiplied with n. So for example, when I look at my second stage, this length was 2 multiplied with 3, and since this is a multiple of 3, I can wrap it around with boxes whose length are 3. And so in this one, this was 1 multiplied with 2. Since it is a multiple of 2, I can wrap it around with boxes of length 2. Therefore, if I am at any nth stage, I can always get to the n plus 1 stage. Now what's interesting about this particular figure is that it will allow us to work with cubes while still staying in the 2 dimensions. So the strategy here is to compute the area of the figure in the nth stage in 2 different ways. And of course the 2 different ways I'm talking about will be first in terms of the sum of cubes, second in terms of the sum of natural numbers, and then we should be able to come up with some equality. So the first method through which I'm going to calculate its area is that we need to notice that if I look at the first stage, I chose 3 squares of length 1, right? In the second stage, I had to add 8 squares of length 2. In the third stage, I had to add 12 squares of length 3 because I have to wrap it around. So in general, it turns out that for the nth stage, in order to get to the n plus 1, in order to get to the nth stage, I have to add 4n squares whose length will be n, of course. So the area will be the sum of these. In other words, be 4 multiplied with 1, which was the length, and I square it because the area of a square is the length squared. plus 8 multiplied with 2 squared plus 12 multiplied with 3 squared all the way to some 4n multiplied with n squared. Now this actually, so this is equal to, the area is equal to this, and this is my first method. Now we can notice that since these are multiples of 4, it so turns out that this is 4 multiplied with 1 multiplied with 1 square plus 4 multiplied with 2 multiplied with 2 square plus 4 multiplied with 3 multiplied with 3 square, and all the way up till we reach some 4 multiplied with n multiplied with n square. So this would be equal to 4 multiplied with 1 cube plus 4 multiplied with 2 cube plus 4 multiplied with 3 cube all the way to some 4 multiplied with n cube, right, which is actually just 4 into the sum of cubes, 1 cube, 2 cube plus 3 cube plus all the way to some n cube. So we're done with half of our deal, that we calculate the area in terms of this. Now we need to figure out to express the same area in terms of sum of the first n natural numbers. Now we can look at this square as a whole, and we can try to calculate its area by multiplying its total length by itself. So here we saw that the length, the outermost length, was n plus 1 multiplied with n, but if I try to use this, it won't really be of that much use to us. Instead, what we can do is we can look at their projection. So if I start from here, this much, considering I am looking at the third case, this much would be length 3, and from here to here this much would be length 2, and from here to here this much would be length 1. I'm just copying it off from here, right? So here's the projection, and I've gotten to the half of the circle, half of the square, so I have to repeat this on the other side. This much is length 1, this much is length 2, and around this much is length 3. So in other words, for the third stage, my length will be 2 times 1 plus 2 plus 3, right? And so in general, my length, so this is my second method, in general my length will be 2 times 1 plus 2 plus 3 all the way to some n, and this is the length, so I need to square it to get the area, which turns out to be 4 into 1 plus 2 plus 3 all the way to some n squared, and this is equal to the area. So we've expressed the area as sum of cubes, and we've expressed them as sum of natural numbers squared, and of course the area is the same. So in other words, 4 times 1 cube plus 2 cube plus 3 cube all the way to some n cube is the same as 4 times 1 plus 2 plus 3 all the way to some n squared. 4 cancels out on both sides, and we reach our conclusion that 1 cube plus 2 cube plus 3 cube all the way to some n cube is always equal to 1 plus 2 plus 3 all the way to some n whole square, and we are done. QED. See you in the next video.